So, welcome to this next lecture. Till now we had referred to steam tables, and if you remember around the first lectures, I had said that there are two ways to get properties of water, and one of the methods was the graphical method. So, I had referred to there are two methods, graphical method and tabular method. Till now what we had seen is a tabular method which is accurate, wherein I get all the properties to the decimal points which is based on interpolation, but I can't see the process graphically here. Now I am going to talk about is the second way of representation of the properties. At the same time I can see graphically how the process takes place, which actually can give you a lot of information which the tables cannot. And here now therefore I am referring to Mollier charts. So, this I will talk about introduction to Mollier chart or Mollier diagram, which is basically an HS diagram, enthalpy entropy diagram, enthalpy entropy chart. We will see some salient features of this Mollier chart, Mollier diagram, and I will just show a small application of Mollier diagram. I will also tell you one fact here, that this Mollier diagram I will not refer all the time. It is actually useful to tell you how the process takes place. What is the state of the process, what is the state of the point when it starts, when the process starts, and where does it finish. You can get a lot of information from that chart, but you can't get actual accurate properties from this. So, we will not refer to this Mollier chart all the time, we will not even solve the problems, maybe some simple problem, but mostly we will refer to steam tables only for acquiring properties at different states of water. This photograph is of Richard Mollier, who came from Dresden, Technical University Dresden, Germany, life spanning from 1863 to 1935. Mollier is known as a pioneer for experimental studies in thermodynamics, mainly related to water, moist air and steam. The major contribution from him, enthalpy entropy chart or HS chart or Mollier diagram. This is really the biggest contribution that has come from Mollier as a scientist. These charts were created in 1904, and just an historical fact, at the 1923 thermodynamics conference in Los Angeles, it was decided to name any thermodynamic diagram using the enthalpy H as one of its axes as a Mollier diagram. So, whenever you have got a graphical representation in which one of the axis is enthalpy or H, one can actually refer to it as Mollier diagram. Not so much prevalent in practice, this nomenclature, but still a fact which we all should remember. Let us come to the Mollier chart and let us have a look at its salient features. So, as is known now, it is an enthalpy entropy chart, enthalpy on y axis, entropy on the x axis, and it would look like this. What you see here is a little bit inclined enthalpy entropy diagram, and on this diagram I have drawn several lines, and this is the speciality of Mollier chart. What you see on these lines are, these two extreme lines are the x lines. In fact, all these are of basically x lines, and this is saturated liquid line where x is equal to 0. Mollier's chart basically represent so much of dryness fraction, the lines of dryness fraction which we do not see on the steam table or even on phase diagrams. And here one can directly read the value of x from Mollier chart, and which is one of the highlights of this chart. So, obviously when I say x is equal to 0, it is saturated liquid line, and the other point therefore should be x is equal to 1, which represents saturated vapor line. So, this is x is equal to 1, x is equal to 0, and then you can see all these other values definitely will be other values of x. But then when I say this is saturated liquid line and saturated vapor line, they should meet each other at the critical point. So, this is a critical point, all right. all other lines shown here schematically are the constant dryness fraction line, that means x values. So, this could be 0.1, 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, so on, somewhere here x is equal to 0.9 and things like that. So, what one can also understand from this is the enclosed region between these two would be the wet region or a two phase mixture, vapor plus liquid together, and on this side will be the single phase region, on this side especially. So, this is my wet steam, wherein we say that entire thing is less than x is equal to less than 1, and above what I call it a superheated steam, where in this region we will have a superheated steam, all right. We can have in the same diagram various pressure lines, and the pressure range is from 0.01 to 1000 bar, all right, similar to what we have in steam tables. We got pressure range 0.01 to 1000 bars, and these pressure lines would be shown like this. So, you can see various constant pressure lines across here. In actual Mollier chart, you will have the pressure values given over here. In addition to that, what we have also are the temperature lines up to 800 degree centigrade, all right. You can see there are various constant temperature lines which run like this. They have not been shown over here, but you can always see that the temperature lines will go through the wet region also, and therefore, we got a pressure, we got temperature, we got dryness fraction. In addition to that, we can read enthalpy, entropy from this. Then we got a constant specific volume lines also, various lines, all right. So, in all we got various line, and therefore, lot of data is embedded over here in a graphical format. So, I can actually just find a point and read all these properties directly from this graph, which I cannot do from the steam table. From steam table I have to locate these values, interpolate, all right, but here I can, the moment I know the point where it lies, I got an idea in which zone it is straight away, and corresponding to that point I will read the properties. So, lines are plotted on HS chart, and it has constant pressure line, constant temperature line, constant volume line, and constant dryness fraction line. So, all this information I can get directly from Mollier chart, and that is a very effective information one can have, one can acquire, all right. And if I could draw processes on this, then it gives lot of information about that process itself, not only process but even cycle also.